Brian deposits 100 at the beginning of each month for 10 years. Timeline. At the beginning of each month, so it's going to be like this: 100, 1, 2, 3, 4, 5, 6, so forth. Keep going. And the last one would be here, 100, for 10 years. In an account earning 3% nominal interest, convertible monthly for the first 6 years. Okay, so first 6 years, let's make that here. 6 years, 10 years. And this interest rate, 3% nominal interest convertible monthly. So let's write that as I-12 equals 0.03. And nominal interest, 4% convertible monthly for the remaining 4 years. I-12 equals 0.04 for the remaining 4 years. That's Brian. Bill deposits 200 at the end of each month into another account earning annual effective interest rate I. Okay, so now Bill's timeline, also for 10 years. 200 at the end of each month. So Bill's deposits will start at time 1 month. At the end of each month into another account earning annual effective interest rate I. At the end of 10 years, both accounts have the same accumulated value. Find I. So this guy, Bill, at the end of each month into an account earning annual effective interest rate I. So for this guy, they're giving us the annual rate, but the deposits are happening monthly. So I have to convert, right? So 1 plus I 1/12, which is the same as I-12 over 12, to the 12th power is equal to 1 plus I. Therefore, 1 plus I to the 1/12 equals 1 plus I raised to the 1/12th power. And I 1/12 is equal to 1 plus I to the 1 over 12 minus 1. That's for Bill, because his stuff was given in terms of annual effective interest rate I. And they want the accumulated values to be equal. So accumulated value of Brian equals accumulated value of Bill. Can you give me an expression for the accumulated value of Brian? Can we start there? What do you say? 100 what? 100. No A. I'm talking.
S angle.
Right. S or S double dot?
Double dot.
Right. S double dot, because the payments are starting immediately, right? 100 S double dot angle what? Talk to me. I want to hear your thoughts.
Angle I.
Well, it's monthly, babe. So no 10, right? 10 is the number of years. It's monthly. Be careful. The interest rate changes right here. The interest rate changes here, so I have to be right. 100 S double dot angle 72 at the monthly rate, right? What is the monthly rate? I don't know yet, so let's find it. I-12 is 0.03, so I-12 over 12 is 0.03 over 12, which is 0.0025. And let's do the same for this one because these payments are also monthly, right? So I-12 over 12 here is equal to 0.04 over 12, which is 0.003 repeating. So now I have the monthly rates. Okay, so let's continue. 100 S double dot angle 72 at the first interest rate, 0.0025. And that's here. That's here. So if I want the accumulated value at 10 years, I'd have to grow that, right? I'd have to grow that this way for 1.003 repeating, because this is the interest rate that you're growing it at. 1.003 repeating raised to the what power? 48? 48, because I have 4 years here, 12 months each. So 48 power. So notice I use the monthly rate from here to grow this accumulated value, which was this. Follow me? Plus what? How about these payments now? 100 S double dot angle 48. There are 48 payments at 0.003 repeating. That's the accumulated value of Brian. Please argue with me if you don't agree so that I can convince you. Notice what I did. I found the accumulated value of these, and then I grew it with this interest rate, plus the accumulated value of this annuity, which is 48 payments at that interest rate also, right? Okay, now set this equal to the accumulated value of Bill, which is what? Bill's payments are monthly. 200 S angle, how many months? Right, so let's label this 120 months. So 200 S angle 120. Notice it's S because this accumulated value, the last payment will be here, 200, right? So 200 S angle 120 at I 1/12, meaning monthly interest rate. And then you'd clean this up. Right? I think from here you can finish up, because this one is just 1 plus I to the n minus 1 over d, and so is this one, and this one, same thing, 1 plus I to the n over I, right? And you would solve for I 1/12. You could just call it I for now. And it says find I. Are you okay with this? Yeah.
Can you explain the S double dot 72 again?
Yeah, of course. So how many payments here?
It would be 72.
72 payments. The first payment is happening immediately, and you're looking for the accumulated value 1 period after the last payment at that interest rate.
Okay.
So there is another payment of 100, but we're going to include this one with these guys, because that's where the interest rate changes. So it's like this. So this 100 doesn't belong to this payment stream. Follow me? Yes.
What's the difference means between the S dot dots and the S?
Okay, let me draw a picture so you can see. So let's say I have a payment here, payment, 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 and I'm looking for the accumulated value here, right? This would be P times S double dot angle 3, I. Notice that I'm looking for the accumulated value 1 period after the last payment of P. If I were looking for the accumulated value here, and this was P, P, P. This would be P, S angle 3, I. Doesn't matter about the starting point and all that. See, it doesn't matter here. You could just say like that. You follow what I mean? But because the last payment occurs at the time when the accumulated value is being looked for, this would be S angle 3 because there are 3 payments. This one would be S double dot angle 3 because I am evaluating this accumulated value 1 period after the last payment. Okay, similarly for A, if the first payment occurs here and the next payment occurs here and you're looking for the present value here, this would be P, A angle 2, I. Follow me? You know, I just need to fix this because otherwise I have to hold my paper crooked the whole day. Okay, so PA angle 2I would be the present value here. But if I wanted the present value here, then this would be PA double dot angle 2I. Do you see the difference? This has to be very clear in your mind, otherwise how can you proceed? So this number is just the number of payments. The double dot or the lack of the double dot is determined by whether the payment is right now or whether the payment is 1 period from right now. Any question? Okay, so I'm calling this page, do we have an 8A page? 8A. All right, so continuing, you can finish this up, right? And solve for I 1/12. And then lastly, find the annual rate. Oh my goodness. I do have?
Yeah, this is on page 9, I think.
So can I call this 8B? Would that be okay?
If you want to call it 9A.
I don't, because I want you to look at it before this page. I want the next group of kids to look at it before. Or the people who are not here. Because if that's understood, then they can go do this problem, right? Okay, so solve for I-12, and lastly, find the annual rate I. How would you find the annual rate I? You would do this. 1 plus I, annual, equals 1 plus I 1/12 to the 12th power. So the whole idea here is I need you to be able to translate to this thing right here. After that, it's easy. Let's do the next one. Annuities with payments in geometric progression. A 30-year annuity immediate. So let me do that. 30-year annuity immediate. That means the first payment will be later. 30-year annuity immediate with end-of-year payments. So this is 1, this is 2 years. Has a first payment of 400. Subsequent payments increase by 6% each year. So this one would be 400 times 1.06. The next one would be 400 times 1.06 squared. The fourth one would be 400 times 1.06 cubed, and so forth. The last payment is at 30, and the last payment would be 400, 1.06 to the 29th power. Every time you're multiplying by 1.06. So it's getting bigger and bigger and bigger and bigger. And the question says, find the present value or the price of this annuity based on 7% interest. So I equals 0.07. Find the present value right here. Present value is the price. The price you would pay for this annuity is the present value of the stream of payments, right? So, in your notes, I posted a page that looks like this, which says annuity with payments in geometric progression. And what I did here was I started at time 1 with a payment of 1, and at time 2 with a payment, this is a payment of 1 plus G. So it's like this, 1 plus G. And then this one is the previous one times 1 plus G, and so forth. And we summed this. I asked you to look at this before you came back today, right? Turns out that the present value of this is found to be the bottom line here, which should be memorized, is P times 1 minus 1 plus G, where G is the rate of growth, over 1 plus I, where I is the interest rate, to the nth power over I minus G, where P is what you're starting with. So in this case, P was 1. So you have to be careful. P is the deposit or the payment at time 1, and you're looking for the present value here at time 0. So you have to set it up when you're doing your problem. You have to make sure that you are looking for the present value one time period before the first one, which will be P. You don't want to do it here, otherwise it's going to involve double dots, and you're not going to have memorize the formula for that one, okay? And I'll explain what I mean when I do the problem. Yeah.
Can you only use the geometric annuity for present value? Like,
No, if you want to do the accumulated value, you would just grow it to n.
oh,
Right? So as with every other annuity, if you have the present value and you want the accumulated value, you just go times 1 plus I to the nth power and you're done. So once you have one, you have both. Okay? So let's use this formula here. So it says find the present value or the price. So it would be, I'm using this formula, P 1 minus 1 plus G over 1 plus I to the n over I minus G. And then it's just a plug-in. So my P is 400 times 1 minus 1 plus the growth. The growth is 6%. So this would be 1.06 divided by 1 plus I is 7%. So this would be 1.07 raised to the 30 power. That's my n. Close the bracket. Divided by I minus G. I is 7%, G is 6%. So this turns out to be 400 times 24.54941222, and your answer is 9819.76. It's purely a plug-in after you realize that it's geometric, and you plug into the present value of the geometric annuity formula. Get it? So would I ever expect you to reproduce this thing right here? The answer is no. Just understand it one time and then start using the formula. That's it, right? So just in case, just so you have it in your notes, if I wanted the accumulated value, this would just be the present value, 9819.76, times 1 plus I to the 30 power. Finished. 1 plus I to the 30th. Get it? Let's do the next page, page 10. 9. Do you think I could borrow somebody's page 10? I don't know what has.
Yeah, sure.
Yeah? And then I'll just scan it in.
Yeah.
Thank you.
So for the accumulated value then, like would you still have to like account for the fact that the value is growing with that initial 6%? Like how what would you do?
So the interest rate throughout is I, whatever I is, 7% in this case. So once you have the present value of a stream of payments, to get the value at a later date, you just grow by 1 plus I to the n. You don't have to worry about the growth of, what was the growth there, 6%? You don't have to worry about that. You took care of that already. Can I write all over your notes?
Yeah, sure.
You sure?
Yeah.
Okay, so I'm here. I'll be neat. So it says, you can ignore all this stuff. This is the stuff we just talked about, okay? And it also says that this happens to be equal to P1 plus I to the -1 A double dot angle NJ. I don't think it's to your benefit to waste time trying to derive that. Once you have the formula for present value, you can just move on, okay? Let's do the next problem. Ted purchases a 15-year annuity immediate with annual payments, okay, 15-year. 0, 15. The first payment is 100. And each subsequent payment increases by 2%. So 100, 1.02, and 100, 1.02 square, and this one would be ... 100, 1.02 to the 14th power. The purchase price was based on annual effective interest rate 5%. I is equal to 0.05. Find the price. So, straightforward. Present value equals price equals, let's plug into the formula, P 1 minus 1 plus G over 1 plus I to the n divided by I minus G. So in my case it's 100, 1 minus 1 plus the growth is 2%, so 1.02 divided by 1 plus I, 1.05 to the nth power, 14th power, over I minus G. 0.05 minus 0.02. And this turns out to be 1175.38. Straightforward. Yeah.
Can you explain why n here is 14 and not 15?
Because I made a mistake. Thank you. 15th power. Thank you. Any question? Okay. The next one is annuities with payments in arithmetic progression. So it says, consider an annuity with payments P plus QJ minus 1 at time J. Let's draw a timeline so you can see immediately what I'm talking about. 0, 1. At 1, you have a payment of P. At 2, you have a payment of P plus Q. At 3, you have a payment of P plus 2Q. At n, you have a payment of P plus n minus 1Q. So this time you're adding the same amount to each payment. Say the payment goes up by $100, like that. So at time 1, you have a payment of 1,000. At time 2, you have 1,100. At time 3, 1200, like that. So let's see what it says here. Let blank denote the present value of an annuity one period before the first payment with payments in arithmetic progression lasting n periods with effective interest rate per payment period I. So this is called let I, P, comma, Q. And since I'm talking about present value, this would be A, angle N, I. That's the present value of an increasing annuity, immediate. So the I stands for increasing. The P stands for the first payment, one period after the time where you're taking the present value. The Q stands for the increment. The A tells you that you're taking present value, not accumulated value. The N is the number of payments at interest rate I. Are you with me? Of course. I means increasing, increasing annuity. So I, because it's increasing. P is the first payment. And it's one period later, right? You see how the first payment is at 1, not where I'm taking the present value, right? Q is the increment, meaning how much are you adding each time? And A, because you're taking present value. And N is the number of payments. And I, of course, is the interest rate per period. Remember, the interest rate has to match the period, right? So if you're talking about 1 year, it has to be the annual rate. If you're talking about 1 month, it has to be the monthly rate. Okay, so next page. So next page, what you'd have to look at is this page that I put up in your blackboard, where it gives you the formula. There are 2 formulas that you must know, okay? Let's write those down, nice and big. The first one is the present value of the arithmetic annuity. So what page should this be? 10A? Present value of arithmetic annuity. And this is on that page that I posted up, but let's just cut to the chase here. Present value of the arithmetic annuity, I, P, Q, A, angle NI, is equal to P, A, angle NI, plus Q over I, A, angle NI, minus NV to the N. Yes, you're going to memorize this. You will actually, if you're taking the actuarial exam, you will memorize it. But if you're taking my exam, you get a little cheat sheet, right? A little 3x5 index card, both sides. So you can write it down on that. And then the accumulated value of the arithmetic annuity. I, PQ, not A, but what do you think it would be if not A? S, angle NI, equals. Now remember what I was telling you, that the accumulated value is obtained by multiplying this one by 1 plus I to the N? So I'm going to do that. P, when I multiply this by 1 plus I to the N, I'm going to get S angle NI plus Q over I, S angle NI minus N. Because when I multiply V to the N by 1 plus I to the N, they will cancel. So this one, this term will not have a v to the n in it, because when you multiply by 1 plus I to the n to get the accumulated value, that disappears. Okay. So memorize this one, and then if you need the accumulated value, you'll just look at this and change all the a's to s's and drop the v term, v to the n term. Are you with me? Okay. So now page 11. Please refer to the scanned blah, blah, blah. Yes, you got that. Let's do the first problem. Find the present value of a 17-year annuity with annual end-of-year payments, the first of which is $3,000, and each subsequent year the payments increase by $200. So at time 2 the payment would be $3,000 plus $200. At time 3 it would be $3,000 plus 2 times $200. And at time 17 it would be $3,000 plus 16 times $200. And it says find the present value. So it's a plug-in. I, get used to this notation, okay? I, 3,000, that's my P. My Q is 200, that's the increment. A, for present value. Angle 17. At what annual interest rate? 4%. You want to make sure that the payments are annual, so the interest rate is also given annual, right? If they gave you the nominal interest rate convertible monthly, you would have to first change it to annual in order to use it. Okay, so let's go. This is equal to P A angle N I plus Q over I, A angle N I minus NV to the N. So let's plug in. Is equal to 3,000. A angle 17I plus Q over I, that's 200 over, what's my I? 4%, 0.04. And let's change this one also to 0.04. We don't need to keep saying I, we know the interest rate. 200 over 0.04 times A angle 17.04 minus 17 v to the 17th power. And then you clean this up. 3,000 times, let's go somewhere else and figure out A angle 17.04, because you notice that I need that twice, right? So go somewhere else. A angle 17.04. What's the formula for A angle N? 1 minus v to the N over I. So I have to figure this out on my calculator. What would it be? Can you get me a number? One minus v to the N over I. I got 12.16566885. Make sure you get that. And then go and plug this in here. 3,000 times 12.16566885 will give you 36,497.007 plus 200 over 0.04 times 12.16566885 minus 17 over 1.04 to the 17th power. That one gives me 17,191.618, where A angle N equals that. So my final answer is 53,688.63. Where it's this plus that. Doable, right? And that's the end of this packet, right? Everything else is examples from old actuarial exams, which I will certainly do as we go on. We still have some time, but I want to do some very pertinent problems here today. So this is not in your notes if you would take it down. Will you send me a scan of this? Or is it easier for me to rip it out and send you a scan of it?
I can scan it tonight.
Sounds good.
Yeah.
You won't forget, right?
Yeah. No.
Thank you. Okay, so take down these problems. I have a perpetuity immediate. I have a perpetuity immediate paying 1,000 at year end for 11 years. And then payments increase by 180 each year. I is equal to 0.05. Please find the price of this. And somewhere I should say forever, right? And then payments increase by 180 each year. And this goes on forever. Because after all, it's a perpetuity. Let's draw a number line. So time 0, nothing happens. Time 1 pays 1,000. Time 2, 1,000. And this occurs for 11 years. So here's time 10, 1,000. Time 11, 1,000. And then at time 12, the payments start increasing by 180. So this would be 1,000 plus 180. And at time 13, 1,000 plus 2 times 180. And so forth, forever, forever. Find the price. So I have to break this up into two pieces, the piece without the increase and the piece where it's increasing. So this is what I was talking about before as to when you have to be really careful where the P is, right? So I'm going to say this is 1,000 A angle 10 at 0.05. That would bring me to here. Because I want to include this 1,000 in the increasing piece. This is going to be the increasing piece where this is P. Get it? So I won't say A angle 11. I will say A angle 10 right now. So 1,000 A angle 10, 0.05 plus I, P, which is 1,000. That's P, comma, Q is 180. A, angle infinity, 0.05, divided by 1.05 to the 10th power. Look what I'm doing, guys. I'm finding the present value here of this increasing annuity where P is 1,000 and the increment is 180, and then I will bring this back this way because The present value would be at time 10, not at time 0. And I want the present value of this increasing perpetuity at time 0. So I would have to discount 10 years. So this one is because I'm discounting 10 years, meaning bring it back. Are you with me or no? So this one would be 1,000 times 1 minus v to the 10 over 0.05 plus 1 over 1.05 to the 10th power, that's the discount factor, times, and now I have to come up with this. But I need it at infinity, right? So what's the formula? What's the formula? P over, guys, what's the formula for arithmetic annuity? PA angle N plus Q over I, A angle NI minus NV to the N. Correct? Yes or no? Only your N is infinity because this is a perpetuity. So let's change it. A angle infinity I plus Q over I, A angle infinity I minus infinity V to the infinity. Right? So this is going to be a little bit of a problem. I have to fix that by L'Hopital. So let me go somewhere else right now. So aside, what is the present value of an increasing perpetuity? If I could get that, I could go back and plug it in here and be done, right? What is the present value of an increasing perpetuity? That's the question. So I want the limit as n goes to infinity of PA angle NI plus Q over I, A angle NI minus NV to the N. That's what I'm after, really. Because if I had that, I could go put it in here, right? This would be this. So let's take the limit as n goes to infinity. So I have PA angle infinity I, but this one, I know that A angle infinity I is 1 over I. Remember that? The present value of a regular perpetuity is 1 over I. So P times 1 over I plus Q over I times, so here I have plus Q over I, A angle infinity I. That again is 1 over I minus Q over I times N, 1 plus I to the N, and I want the limit as n goes to infinity of this mess. So for that I need to do L'Hopital because I have an infinity over infinity situation. Follow me? So L'Hopital. So let's take the derivative of the top and the derivative of the bottom because I have an infinity over infinity situation. So this would be 1. That's the derivative of n. And what's the derivative of 1 plus I to the n?
N times 1 plus I to the n minus 1.
1 plus I is a constant. So it would be 1 plus I to the n ln 1 plus I. Agree? And I want the limit as n goes to infinity of this mess. So I have infinity situation on the bottom and a 1 on the top, that part will go to 0. Just that end part, just this part will go to 0. Agree? So basically, I just have what I have here. P over I plus Q over I squared, because this mess went to 0. So it's just P over I plus Q over I squared. It will behoove you to memorize.